Okay, consider this to be a difficult integral. And I want to point out the way I'm going through it. If you found a better way to do it, or, I would say if you think you found a better way to do it, we'd love to see it, all right? So again, I would love to see if you found a different way of doing the problem over here. So what I want to go through, what I did to do the integration. I said u was equal to, and I see that right over here. I know what u is equal to. I cubed both sides, relatively simple, by the way, and then I differentiated both sides. And if you did that, you get 3u squared du, the derivative of tangent secant squared dx. What I notice over here, some Pythagorean identities over here. I'll write down what I mean by that. That the sine squared theta plus cosine squared theta is equal to 1. The most famous Pythagorean identity, by the way. But you could divide both sides by cosine squared, and what do you get? You would get tangent squared theta plus 1 is equal to secant squared theta. And that's why I'm putting this down over here. I'm saying the secant squared theta is the same thing as tangent squared of theta plus 1. Of course, I'm using the letter x in this problem over here. Then I made my substitution. Let me go through that with you. So the original integral I had was a cube root of the tangent of x dx. I made a substitution, and that substitution is the cube root of tangent is going to be u, and then the dx is equal to what? Well, let's take a look at that. This is the dx, right? So what's going to be equal to? Well, let's write this down. It's going to be, let's see, it's going to be 3u squared du over this, right? Dividing both sides by that. Well, that's going to be u6 now, because the tangent squared is u6, so it's going to be u6 plus 1. Now, if you do that, what do you get? You would get 3u cubed on top, and you would get u6 plus 1 on the bottom. All right, so I'm going to say this is certainly improved. At least I think it's improved. I got rid of the tangent, and I got things a rational function now. So let me start to erase this stuff over here, and it's going forward. I know that much. All right, so then I said to myself, well, let me try another substitution. And the other substitution I made was this one over here. dv is really easy. The du is easy, 3u squared du. And then I gotta plug it in, all right, and see what happens. I'm hoping for the best, by the way. So let's put this down. I'll put a little double star here. And let's take a look at that, all right? So let's take a look at it. So I'm going to put this down very carefully, by the way. And let me do the bottom first. We're just doing this business over here. And let's see what that would give you. It looks like it would be v squared plus 1. And then I got to write this, the du down, right? So let's take a look at it. And I got some troubles here. I'm looking at this, and I got to write this down. So I'm going to say, let's take a look at that. I got, I'm seeing part of it, but I gotta multiply both sides by the by a u, right? So what do you get? You get u dv is equal to 3u cubed du. All right, and that's what I want. But what's the u? And the u is going to be the cube root of the v. So I write that down now. So cube root of the v dv, and that's where this thing is, right over here. All right, this is where I realize I'm at a dead end. All right, to me it got worse. All right. Now, certainly, someone says, well, what are you going to do then instead? Well, I'm still going to go back to what I think was a good place to be and move forward on that, all right? So I'm thinking this is still a good place to be, and I want to move forward on it. So I make another substitution, a different one, all right? So let me go through that substitution now, all right? So again, we're still working with this integration, and I'm trying to get this to be better. So what I did was I said, well, t is equal to u squared, and dt is equal to that. Fairly simple. Let's go through the substitution now and see what we get. What do you get over there? Well, let's take a look. We have 3u cubed u6 plus 1 du, and that was a star in it. I'm making another substitution, so a double star now. And I got to throw this thing in here, right? So let's take a look at it. And, kind of be careful with it. I'm looking at the bottom first. This is what I do. And what do you see over here? Well, I'm seeing this. I'm going to make a substitution. So I'm going to say I want u6, so that's going to be t cubed then, right? So t cubed plus 1. I got that part covered. And then I got a 3 there. I see the 3. I'm seeing that. I got to get the this over here now. I don't have that yet. So let's take a look at that. And to get that, I'm going to say, I got the dt. Oh, I'm sorry about that. Get my eraser out again. I have the dt over 2 is equal to u du. But I need a u cubed, right? So I'm going to multiply both sides by u squared. Make it u cubed, right? So I got my u cubed du, but I want to get that u squared now. And what's a u squared? Oh, it's just t. So this is going to be t over 2 dt. I think I can write that in. So I'm put the 2 over here, a half, and then I get a t dt. All right, let's see if we are able to accomplish that. And I'm seeing it right over here. So they factored the 3 out, 3 over 2. They get the t dt. And things have improved greatly, by the way. They really have. So what I'm going to do is I'm going to erase everything now. I'm moving forward. We can always go backwards, by the way, because everything's written down for us. And I'm going to concentrate on dealing with this guy now. All right? And to do that, it really doesn't look bad to me. I'd factor it. And if you factor this guy over here, it's a sum of perfect cube, by the way. It factors pretty easily. So things you're learning basic algebra. Then what I did was I did partial fractions. Let me go through that with you, all right? So I'll write this one over here for you. I get t. I'm going to do partial fraction now, and that's going to be t cubed plus 1. And I'm saying that's equal to a over t plus 1 plus, well, I got this irreducible quadratic, t squared minus t plus 1. I'm going to say bx plus c. Multiply both sides by the LCD, and you would get t equals a t squared minus t plus 1 plus bx plus c times t plus 1. Wow, that's a lot of work. So I'm going to say t is equal to minus 1. And if you did that, you would get minus 1 equals, well, the second term disappears, but the first term becomes what? 3a. So now I know a is minus 1/3. Let me go up here and erase the a. And let me just get my eraser out. I'll make it a small eraser. And I'll put down the minus 1/3 now. All right, I got to get the b, though. All right, and the c. So I'm going to say t is equal to 0 now. And I would get 0. Let's see, I would get minus 1/3 for the first term. Plus the second term, if x is 0, I'd get c. That's not so bad. So now I know the c is 1/3. All right, this is pretty good news, by the way. So I can get my eraser out again. And I'm going to erase this c over here. And I'm going to put down 1/3 now, plus 1/3. All right, I still got to get the b. How to get the b? I'd set probably the t to be 1 now. And what would that give you? You'd certainly get 1 on the left-hand side. By the way, we're plugging it in here. And then what do you get on the right-hand side? If I chose 1, right, I'd get 1 minus 1 plus 1. So I'd get just the a. So the a is minus 1/3 again. Plus, I would get b plus the c, which is 1/3. And then what do you get? You get 1 plus 1, which is 2. All right, so I'm going to do it. And what do I get over there? I'm certainly kind of running out of room over here. But let's see, I'll add 1/3 to both sides. So I get 4/3 is equal to b plus 1/3 times 2. I'll divide both sides by 2. I get 2/3 equals b plus 1/3. So now I know clearly that b is 1/3. I didn't make any stupid mistakes, by the way. So let me erase the b now, and I'll put the 1/3 down. All right? I want to show you where this is in the notes now, and that's what we're doing. We're kind of moving forward. All right? And let's take a look. I want to see if I can see that. All right? So we're taking, I'm going to start to erase things, by the way. I'm going to erase this business here. I don't really need that highlighted anymore. I don't need all this side work anymore. I'm kind of done with that. Whoops, I didn't mean to do that. Let me just erase again. Sorry about that. I went too far on the erasures. Let me erase this business over here. I'm going to clean it up a tiny little bit because I want to get the integrations they have written down now. This is my struggle at this point. Okay, let me write this down for you. And the way I'm going to do it is I'm going to rewrite these guys as, I'm going to pull out a 1/3. And you would get x plus 1. Whoops, I forgot, that's not an x, that's a t, by the way. Sorry about that. I had x on my brain. Let me erase this over here. So it's going to be t plus 1 over t squared minus t plus 1 minus 1 over t plus 1. All right, and that's, that's the integrand. All right, so I kind of pull it out, and what am I left off with? Something fairly simple. And I'll write that down for you. Certainly pull out the third. So when I'm pulling the third in here, I'll be left with a half. And then what do you get this, I wrote this one a little bit differently. I wrote it as 1 plus t. It doesn't really matter. T plus 1, 1 plus t doesn't matter. Over this, and I get this. Yeah, looking pretty good. All right, and then what I do, I start to realize that it's really not a bad integration. It's getting better for me. Let me get my eraser out again. And I'm going to erase all this stuff over here. And I want to concentrate on the next series of steps that I go through. All right, so I have this. And what I do is I split it into two. So the half comes out. I got this first integration over here. I'll talk about how I got the bottom later. And I got this integration over here. Let's go through the bottom, by the way. The t squared minus t plus 1 is an irreducible quadratic. All right, so write this over here. So the t squared minus t plus 1 is an irreducible quadratic. What do we do with that? We complete the square. So we would get t squared minus t. Half the coefficient of minus 1 is minus 1/2 and square it. That would give you a quarter. But I want a 1, so plus 3/4. And what I do over there, that's going to be t minus 1/2 squared plus 3/4. And we have a particular way we like to rewrite those guys, and I'll just do that. And that's going to be t minus 1/2 squared plus the root of 3 over 2 squared. That gives you 3/4, by the way. And then I'd factor it out. Let me get my eraser out again. And I'm gonna factor out, because I want that to be a 1. And let's just do that, all right? So I'm going to factor out, let's see, root 3 over 2 squared. And I'm factoring that. What would I get? I would get 2 over root 3 squared times t minus 1/2 squared plus 1. All right? So let's keep going with that. I want to see if I get that thing going. And let's take a look at that. And I'm kind of looking at the inside, and I want to point out I'm definitely seeing the 1 part now. All right? And I'm seeing the top. I mean, that's just 1 plus t. All right, let me just see if I'm getting that bottom part. And I'm looking at this, and I want to make sure it's this thing over here. And it sure does appear to be that way, because I'm just bringing that 2 over root 3 on the inside, and you would get 2 root 3t, and then you would get, minus 1 over root 3, all right? Now, what I want to do is I want to make sure I'm getting this number over here, all right? So I'm kind of like pulling that out, and remember, it's in the bottom, all right? So what would that be? That would be 3/4, and I'm taking a reciprocal of that, which would be 4/3. Now, look, that stands to reason, by the way. Let's keep moving. We're at this stage over here, and I'm going to kind of split it into 2 different parts, by the way. So I'm seeing what I consider to be easy, and I still think that it might be more difficult. This integration's easy. I think I might want to do that one first, and I do. What would I get? Minus 1/2 times this thing over here. Easy integral. You can't beat that one. It's just really super simple, all right? So I get this over here. That's easy. And then I got to go back. And someone says, I don't even remember what t is. Well, you go back and read. That's why we write things down. This is what t is. So I went back to that. I made the substitution. I get this over here. And then I said, I wonder what u is. I don't remember what u is. So I go back over here. And this is what u was. I go back and plug it in. And you get this over here. All right? Now, by the way, I can remove the absolute value symbol, but let's not worry about that right now. But I'll be honest with you, the reason I can do that is I know this is a positive number on the inside, all right? So you could write down minus 1/2, the natural log of the cube root of tangent squared, x plus 1 plus c1, first constant, okay? The second integration, though, is more difficult. There's more effort that's required over there. So I made another substitution, right? Another substitution. Let me just write down the integral that we're trying to do now, and I want to point out what we're trying to do over here. I don't want to lose track of it. I'm going to outline this for you. We're trying to do this integration over here, which if you multiply that through, it's going to be, let's see, 2/3 of this crazy-looking integrand over there. Let's put out where that is, right over here. And we got to go through that. I made another substitution, and this is the substitution I made over here. All right, this is typical. Right? We've seen that before. So if you did that, you know, the dw is fairly easy to do. I guess I'd multiply both sides by √3. You get this over here. And I'm sorry, no, I didn't do that. I multiplied this by √3. Let me go through that with you. You would get √3 w equals 2t minus 1. And someone says, what are you looking for? Well, I'm really looking to come up with the t in this case over here. So you get √3 w plus 1 over 2 is equal to t. And then I want really t plus 1. And why is that? I'm seeing that right over here. So if you add 1 to both sides, you get √3 w plus, well, let's see, it'll be 2 over 2, so plus 3. Whoops, I moved 2 plus signs down there, didn't I? Plus 3. And that would be over 2 would be equal to t plus 1. All right? So I'm seeing that. It's right over here. And I kind of plug it in. All right, let me get my eraser out now. I'm kind of going to do all my substitutions now. I got everything written down for you. Let's take a look at it. This is my third substitution. Getting crazy, right? Let's write this over here. My third substitution. Be a lot of going backwards over here. So the 1 plus t is going to be what? That's going to be √3. You know what? Let's put the 2/3 down too. That's going to be the √3 w plus 3 over 2. I got that part covered. I have the bottom now, which is going to be w squared plus 1. And do I have the dt? I do. And that's going to be, it's right over here, by the way. That's going to be √3 over 2 dw. All right, I got to simplify that and see what I get. All right, I got to simplify it and see what I get. And there's a lot of numbers pulling out, right, aren't there? So let's take a look. And I'll do it kind of carefully, but I want to see if I get what I want, right? And so this is, what do you want? I want to see if I can match this guy over here, all right? So the first thing I would do is probably just get those numbers out, and that's going to be 2/3. I'm going to factor out √3 over 2. I'm going to circle what I'm doing over here, and I'm going to, factor out that 2 too, and it's over here 1/2. And let's see what we get over there. Well, I'm going to say, what do we get there? We get, let's see, the 2's cancel, and we would get √3 over 6. And let me write this thing down. I'm going to start to erase this over here now. All right, get an eraser out. Got the number. Get my eraser. Again, we're trying to aim for something in the K. And what do you get over there? You would get √3 w plus 3 over w squared plus 1 dw. All right? So what I'm doing over there, I'm going to actually, carry the √3 on the inside because it's a little bit easier for me to do that. So I would get 1/6, and you would get, let's see, 3w plus 3 √3s over w squared plus 1 dw. All right? So I'm going to say that's what I'm looking at right over here. All right? I got there. It took me time, but I got there. So 3w plus 3 √3 over w squared plus 1 dw. This got triple stars over here, right? So I'm there. All right, I'm there. And someone says, what are you going to do now? And this is just never ending, but I got to move forward. All right, so I'm moving forward on that. What I'm going to do, I'm going to split it into two separate integrations, right? So again, tough, but I want to write down this 1/6 3w w squared plus 1 dw plus, let's see, that would be 3 root 3 over 6, and that would be 1 over w squared plus 1 dw. All right, I'm going to kind of, simplify this a little tiny bit, and I get 1/2 here. This would be w squared plus 1 dw. Over here, what do I get? I get root 3 over 2, 1 over w squared plus 1 dw. Let's take a look and see if I'm seeing that. And I'm seeing that here. But I'm really not seeing this one over here. And I'll tell you why I'm not seeing it. I'm starting to realize I'm kind of getting sick and tired of doing substitutions. So I insert a 2 here, and that means it's going to be a 4 over there. So that's why you're doing that. I notice that this guy's derivative is 2w. I'm going to do the substitution in my head, by the way, because I'm getting tired. So I wrote that down, and I want to point out where that is. That's right over here. And by the way, I'm at the stage where I can actually do the integration now. And why is that? They're both easy integrals. They really are. Like the second integral is just the arctangent. So what are you going to get there? Root 3 over 2, the arctangent of w. Some integration of constant, called the second one, but triple stars, by the way. And this is going to be 1/4, and this is just the natural log of the absolute value of w squared plus 1. Again, you could remove the absolute value symbol there, because the bottom line is it's got to be a positive number. W squared plus 1 is a positive number. What do I got to do now? I got to go backwards. And my backwards part is always the tough part. I got to make sure the thing's written down. And let me get my eraser out. And I'm pretty comfortable that I'm getting to a certain spot in the K, and I'm over here now. All right, I'm over here. I can make my substitutions, and I go back one at a time. And I'm wondering, do I know what W is? Right over here. So I just plug it in. And, ooh, this is going to be a tough one. So I gotta do the W squared now. All right? So what's W squared? Well, the W is going to be root 3, and it's going to be 2t minus 1. And if you were to square that, that would be W squared would equal to, there would be 3 in the bottom. And what do you get on top? You would get 4t squared minus 4t plus, let's see what you get over there, plus 1, right? Oh boy, that looks tough. And let's see what we got over there. That's the W squared plus 1. Did I do that right? Let's see. Did I square it? That's 2t over root 3 minus 1 over root 3. And then W, 2t minus 1. Did I square it? 4t squared minus 4t plus 1. Yeah, I get 4t squared minus 4t plus 1 over 3. Let's keep going over here. And I'm going to put down 3. No, I'm just going to substitute it in. That's what I'm going to do. I want to do that. And what do you get over there? Well, let's write that down. W squared plus 1 now, right? W squared plus 1. And what would that equal? I can add 1 to that, right? And that would be 3 over 3. So I get 4t squared minus 4t plus 4. Well, isn't that convenient? W squared plus 1 is 4/3 t squared minus t plus 1. All right? And that's it. That's pretty nice, actually. And I'm going to say the reason it's pretty nice over here is that, I'm taking the log of that as a log of a product. So I know there's another constant involved over here. It's the natural log of that. So I just kind of write it down simple, all right? Let me emphasize that again. The log of this product, which is 4/3 times t squared minus t plus 1, it's the log of a number, right? That 4/3, some number, and I just add it to the constant. That's all I've done over here. So I'm adding it to the constant. All I'm doing is, and then there's some other constant over here. So I'm seeing where this comes from. Make sure I did that right. Yep, I got the 1/4. That's always there. And then I got this over here. All right, we just did this part here. All right, the other guy, fairly simple, just a plug in. So I got that over there. So I'm kind of looking at this and I'm wondering, what do I do now? I got to go back to what the T was. And what was the T? And this is always going backwards, all right? So let me erase this over here. Again, we're working forward through the K. We're at this stage here. And I got to remember what T was in terms of U's. Going backwards. Wow. Oh, U squared. That's not so bad. So I just plug it in there, and what do you get? You get this. Fairly simple. You get this. Fairly simple. And then someone says, what do you got to do now? I got to figure out what U is. And do I know what U is? Backwards. Yep, it's the cube root of the tangent. Right? So, whoops, where are we? Kind of forget where you are. Let me write that down. So U is equal to the cube root of the tangent of x. All right? So I plug it in. That's all I have to do. And what are you getting over here? Let's take a look. You would get this. I'm just, putting it to the fourth power. You'd get this, plus 1. I get this business over here. And then I get my constant of integration for that guy over there. So pretty easy. Now someone says, what are you going to do now? I got to pull everything together. So pulling it all together. We did a bunch of integrations, by the way. So we have all this stuff over here. And by the way, I consider this to be done. This is done. However, what some students might want to do is simplify this. All right. Now, I'm not going to simplify it. I'm sorry, I did simplify it, but I want to point out that I once at the web and saw this problem being presented. And the guy presenting the problem, he's really good, by the way. I do recommend that you look this guy up. Black pen, red pen. He's pretty good with his use of pens, by the way. That's what he calls black pen, red pen. YouTube channel, has a lot of YouTubes over there. I believe he's a high school teacher out in California. He has certainly well-motivated students, and his students do really well, I'm sure of it, all right? But anyway, he referred to this as the easiest integral on the internet, or on the YouTube, by the way. I think he's joking around, by the way. But anyway, I think it's worth subscribing to his channel, or at least visiting his channel. I don't subscribe to many channels, by the way. I don't subscribe to his, but I do go back to his channel to look for problems. So someone's looking at this thing over here and wondering how I got this over here. What I did was I pulled the two logs together. All right, let me just outline that for you right over here. This log and this log over here. All right, I'm sorry, I didn't mean to circle a C, by the way. But I want to point out, in order to do that, I've got to write down them with the same denominator. So the first one, the natural log of this thing over here, I'll just put a question mark over there, but I got to get this in terms of quarters. What would it be? Minus 2 quarters, ln, the question over here. And what I did was over here, I pulled this 2 up here, and I squared this. That's where this is coming from. I'm squaring that guy, which is it's not difficult to square. It's an easy square problem. And then this thing is just this top over here. That's all I did over here. I consider it to be a simple form. All right, and that integration is not bad. So if I were, writing an answer key, let me just erase everything over here. I would claim that there's 2 answers that I think would look good to me. And I'm going to say this answer here would look good to me, and this answer over here would look good to me. They're really the same answer, by the way. Thank you so much for paying attention.